Hi everyone, my name is Dr. OGBEMHE. Today we're going to be having a Boolean Algebra revision lecture. Now, Boolean Algebra is a language of digital circuits. It provides the grammar and syntax for describing the logic that underlies the operation of digital circuits. Now, it represents 0, 1. Okay, now I'm going to take you through basic operations of the Boolean operations. Now, the first one is the AND operation. Okay, the AND operation is denoted by this symbol here. Okay, now you have your A, B here. Okay, yeah, this is operation A and B. Okay, now what are the possible combinations? 0, 0, 0, 1, 1, 0, 1, 1. Now, when both are false, you have 0. When one is false, one is true, you have 0, 0. It's only when both are true, and of course, you return the value of 1. Okay? Now, the OR operation yeah, the same thing, similar combination 0, 1, 0, 1. Now, when both are false, you have 0. When one of them is true, you have 1, 1. When both are true, you have 1. Now, the NOT operation, which is a negation, okay? This is let me say negation of A. You have your A, you have your negation of A, okay? You have 0, 1. So the negation of when it's false is 1. The negation of when it's true is false. It's false, okay? Now let's look at more operations. Now let's look at the NOR operations. A, B, okay. Take note of this symbol here. This is notation for your NOR operation. You have your 0, 0, 1, 1. That's the combination possible. Okay. Now, when both are false, you have 1. When one is true, it's false, false. And when both are true, you have false. Now, our XOR. So this is a symbol here. This is our symbol, okay? Now let's look at the combination. 0, 0, 1, 1 here. 0, 1, okay. Now, when both are false, you get 0. When one is true, you have, when one is true, you have 1. When one is true, you have 1. When both are true, you have false. Now let's look at our XNOR A, B, just like others. Okay. Now, take note of the notation. This is the notation. These are the combination possible, just like others. So when both are, when one is false and there's one that is true, it returns a true value. Now, when you have one, I think there is a mistake here. Take this one off here. It's 0, 0. So when both are false, you have a true value. When one is false, it returns the false value. When one is true, it returns the false value. When both are true, it returns 1. Then we have the NAND operation here. So in our NAND operation, we have a B here, just like we have in others. Then take note of the symbol here. It's an arrow pointing up. Okay? The arrow points up. So here you have your, these are the combination possible. 0, 1, 1, 0, 1, 1. Okay? So when both are false, it returns 1. When one is true, it returns 1. But when both are true, it returns 0. Now, quickly, I want us to look at the loss of algebra. So we have the identity law. The identity law, we have that for or and that for and. Now, for the or operation, identity law for or is giving us so then for and, okay. Now, domination law for all now, for all returns a 1. Then for and, returns 0. Idempotent law for all, it returns A. This also returns A. Complement law. Complement law for all this returns 1. Then for and, negation of A, this returns a 0. Okay? Now let's look at commutative. Because, commutative allows us to also switch it this way. So then for and, when you do that for and too, allows us to, commutate. Okay? Then associative. Associative, associative. Sorry about that. Okay. Associative. So associative allow this to be possible. So you have your A and so with associative, this is possible. Or then for and, this also for and this is also possible. So you have your A. So this is also possible. Now for assumption law, for all, this law will help us to be able to manipulate our Boolean algebra. That's why they're very important. So take note. Then for and, we have A, B, now we go to A. Now let's look at simplification law for all. This helps us to simplify and manipulate our algebra. So we have a negation of A here and B. This is equal to, this is a very important law. You appreciate it when we start applying them. Then for and, we have our negation of A and B. This will just give us B. Okay. Now, let's look at this is also very key, distribution law. So we have our A to give us A and B and B. A now let's look at distribution law for all over and. The first one here is the distribution law for and over all. So the next one is the distribution law for all over and. So this will be